Today, I will be talking about the work energy theorem. The work energy theorem is the difference in kinetic energy at the object's initial velocity and its final velocity. We know that kinetic energy equals half mv squared. However, when finding the change in kinetic energy, we see that it equals half mv squared minus half mv naught squared. For example, a 5 kilogram mass moves at 15 meters per second but slows down. The total work done is 615 joules. Calculate the final velocity. For this problem, we set out our equation and substitute for the values we already know, which is 615 joules for the total work done, 5 for the mass, and 15 for the initial velocity. We then solve for v, and we see that the final velocity is approximately 21.7 meters per second. Another example is that a 4 kilogram box is being pulled by a rope with a tension of 20 newtons for 3 meters. If the final velocity is 7.5 meters per second, calculate the friction force. For this problem, we draw a free body diagram and label normal and weight forces. Then, the tension force according to the direction the box is moving in. Then draw the kinetic friction opposing the tension force. We then set our equation, but we know that normal weight, tension, and the friction force are all acting on the box. However, we do not include N nor W because they are equal to 0 due to the fact that they are perpendicular to the motion and they equal 0. So we consider T positive and the friction force negative because it opposes in direction. Then we substitute the values we already know and solve for friction force, which is negative 132.5 newtons.